Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. We will continue about our lesson for kinematic and dynamic. Today we will learn about machine and mechanism. If we look from this illustration, we can take some conclusion. There is have a tree big for this illustration. First is the machine, second is about mechanism, and the third is kinematic change. About three big our lesson today, we can discuss for kinematic change, only for kinematic change. Before it, we can define about the three big mechanism and machine. The first is the machine is a tool to change forward or direct the force to specific goal. For example, automobile engine or sewing machine. How about the mechanism? Mechanism is part of machine that are served to continue the motion, and also force from energy source to work goal. That's a definition about mechanism. And the third is kinematic change, are a combination of several links and joints that are connected and produced to control output motion as a response from a given input motion, maybe equal to linkage. Before we learn about linkage or mechanical change, we must learn about degree of freedom of DOF. What is the degree of freedom? Degree of freedom is a number of independent parameters. There is a need for shows the position of object in space or particular moment. Look at the illustration. We have some pencil. The pencil as an example of a rigid object or connecting rod or link is assumed not to experience deformation during displacement. For the purpose of synthesis and kinematic analysis, then each link is considered rigid and has no mass. This is a pencil on a wall with a position in x-axis and y-axis. This pencil have a direction to x-axis and y-axis. Beside x and y direction motion, pencil have a rotation motion based on this axis. On a mechanism in machine, we have two big parts. The first part is link, and the second part is joint. Link is rigid stick that have at least two vertices or knots that can be connected with other connecting rod. For example, this is a simple link. Simple link have three link and two join, like this. And the second example is complex links. The complex link like this. This is have two link, 1, 2, 3, 4 link, and 1, 2, 3, 4, 5, 6, 7 and 7 join. The link can be classified based on amount of nodes. This is a sample for amount of node. This first sample is link binary. Binary link have two nodes, 1, 2. The second is a link turner. The link turner have 3 nodes, 1, 2, 3. And the third sample is a link quaternion. This link have 4 nodes, 1, 2, 3, 4, and etc. Now the second part of mechanism is join. The definition of join is relationship between two or more connecting rods at the vertex or node, which allow connecting rods to be connected moving with each other. Connecting are also often called a kinematic pair. Join can be classified about a connection type. The first join is pin join. This is illustration for pin join. They have a rotation motion. The second type of join is sliding join. In sliding join have a linear motion like this. I repeat that if two links connected with pin join, they have a rotation motion. And then if two links have a slide or XY linear motion like this, it's called about a sliding join. Join can be classified about with a contact type. There is a two prerequisite for contact type. The first is lower pair and high pair. The first lower pair, if a link connected with a surface or plane, its part. This is for example for lower pair. This revolute join, they have a rotation motion. And the second is prismatic join. They have a linear motion with x-axis motion. And the third is helical join. Same with revolute join. They have a rotation motion. Fourth is cylinder join. In cylinder join have a linear motion with at x-axis and rotation motion. This is combination about rotation and linear motion. And the fifth is a spherical joint. They have 3 motion. One rotation, first rotation, and 2 is second rotation, and third linear motion. And sixth, planar joint. Planar joint have a XY axis motion and rotation also. You can look at this picture. The planar have motion to x-axis, first motion, and the second motion is y-axis, and the third motion is rotation. And then the second joint type is high pair. High pair is if two links have a dot connection contact like this, not surface but dot or line connection. This first picture, we can look at the motion with x-axis and rotation motion, linear motion and rotation motion like this. Only have a dot contact connection. This is a surface of plane connecting link, and the second sample is plane connecting link. This is half rotation motion and x-axis motion like this. This is have a connection contact with a line. The first is a dot connection contact, and the second picture is a line connection contact like this. And the third picture, we can look combination about two picture. This is a combination about dot and line connection, depending on friction which axis. Now we classified about link and join with another classifier, grouping according to DF number or degree of freedom. This is first sample is coupled with 1 degree of freedom. We can look the picture. This is have a 1 degree of freedom rotating pin like this. Only have a rotation motion. And the second picture, you can look 1 motion degree of freedom. This is a linear motion, translating slider, for example. The third sample or the third picture, we can look helical joint, which have a 1 DOF, a degree of freedom with a rotation motion. And the second classified coupled with 2 degree of freedom like this. The first picture, we can look 1 axis, x-axis motion and rotation motion. This is have a 2 degree of freedom, rotation and linear motion. The second picture, you can look a sliding roll slide joint, half joint. This is have 2 degree of freedom. The first motion is at x-axis translation or linear motion, and the second motion is rotation. And the third classifier is coupled with 3 degree of freedom like this. This sample like a ball joint. This is have 3 degree of freedom, 2 rotation, 2 linear motion. And the second picture is 2 linear motion and 1 for rotation motion. 2 linear motion is x-axis direction and y-axis direction. We can discuss about another grouping. This is grouping according to closure joint. They have 2 classified. The first is form close, and second is force close. Form close is joint that stay connected to 2 geometric shapes. For example, like this. Joint connected by geometric shape. This is y-axis direction. Have a geometric shape and only have one direction motion in x-axis. And the second sample is geometric shape like this, sliding and pin joint. This is have a two motion, x direction motion and rotation. And the second joint is force close. This joint, if we stay connected, must have required an outside force like this. This motion have x-axis motion and rotation. They need outside force to connect it between the part. Yes. And then this is grouping according to connection order. If two links are connected in one connection, it is said to be a first order connection. The connection order increases with increasing link in one connection. If we have two links like this, we can say this is a first order connection. They have one joint. If we have a third link and join like this, we can call this have a two joint. Not only one joint is two joint, because increase one link connection and etc. Okay, after we learn about classified or grouping joint and link, we can learn about kinematic diagram. This is a first of a kinematic diagram for link. The purpose for kinematic diagram is first purpose is to facilitate analyze. Mechanism can be simplified into a kinematic diagram. This is to facilitate analysis. The second purpose is the components are described in the form of a frame. Only the size of object which affect motion and so on. Only focus in function. And the third purpose is size is made in proportional scale with the actual mechanism. So we can draw the size made in proportional scale. Maybe you can draw in millimeter paper or another tool like AutoCAD software. Yeah. And the fourth purpose is each link is assigned a number symbol. If link, you can assign with a number or symbol. Maybe and start from the frame as a link 1, and then while join are assigned in a letter symbol to easily for drawing your kinematic diagram. This is for example kinematic diagram for link. There is many link for kinematic diagram. The first sample is link like this. You can draw a link like a line like this. The second link is a link with a specific section. There is a different shape like this. You can draw like a triangle shape like this. This is for specific section. And the third sample is ternary link. They have a 3 knot of link. You can draw like this a triangle shape with 3 joint. Differences about specific section. This is have a same shape, but in a specific section have a 2 joint, only 2 joint. This is a triangle shape, but have 2 knot or 4 joint. Ternary link have same shape as triangle shape, but have a 3 knot or 3 join. And then this is a paneling picture like this, and your kinematic diagram like this, have a 2 line with a 1 knot or join. And then for side sliding link picture like this, you can draw like this, square shape with one line. They have a translation motion or linear motion. And then for cam link, you for this picture you can draw like this, line and cam shift like this. This is for cam. And gear link picture like this, you can draw like this, two circle shape with two knot or two join like this. And then finally we can start to make a kinematic diagram. This is a step to make a kinematic diagram. The first step is specify the fixed link. You can look at a fixed link and assign it a numeric symbol for one numeric symbol for fixed link. All other link move related to it, or another other link is have motion relative to fixed link. The second step is identify all other link including their type. Then provide constructive numeric symbol. The second type is identify the shape kinematic link in a shape drawing like this. This is a link for a specific section. You can draw like this, a triangle with have a 2 knot or 2 join, and 3 have a sliding. This is a sliding. You can draw like a sliding motion like this, like this. The third step is identify its connecting, including its type, then give the letter symbol in sequence. You can identify your join, including its type, and give a letter like A, B, C, D. This is a join symbol. You can give a letter symbol A, B, C, D. If link, you can assign a numeric symbol 1, 2, 3, 4. And the fifth step is determine if anyone focus on particular section. And the last step is make a kinematic diagram sketch like this. Okay, that's all for kinematic diagram. If any question, don't hesitate to ask me. Okay, we will continue for another discuss. Now we discuss about mobility. As you know, the mobility is a mechanical system. It's defined according to the amount degree of freedom. The degree of freedom is a number of input needed to produce output predictable. We can determine the mobility for a mechanism. For example, this picture, a link in field has a 3 degree of freedom. The degree of freedom is 3. We can account this motion. The first motion is x-axis motion direction. The second is a y-axis direction, and the third motion is rotation direction. motion like this. This picture have a 3 degree of freedom. And then second picture, you can look this picture like this. The two unconnected have a 6 degree of freedom. There's a connection joint reduce the number of degree of freedom. If we look this picture, one link have a 3 motion like this, 3 motion each part. If you have a 2 part like this, they have a 3 motion, the 3 degree of freedom each part. Now you can account and calculate the number of degree of freedom as 3 degree of freedom plus 3 degree of freedom. So we can have a 6 degree of freedom. And the third condition, if two links are connected in full join, have 4 degree of freedom. If we have a 2 link like this and join with one pin like this, degree of freedom will decrease because 2 direction is decreased. For this condition, you can account they have 4 degree of freedom, 2 rotation and 2 linear or translation motion, x-axis motion and y-axis motion. And the fourth condition is 2 row slide link connected by half join. If we have a join like this, a row slide link connected by half join, you can count 5 degree of freedom. 2 rotation each part, this part rotation, and for one part have 1 translation motion to x-axis like this, and the second part have 2 translation motion, x-axis motion direction and y-axis direction motion. And now we can determine of mobility of degree of freedom with some equation from Gruber-Kurzbach. Gruber-Kurzbach equation is to determining a number of degree of freedom. This equation is m equal 3 multiplied l minus 1 minus 2j1 minus j2. M is mobility, for mobility, L for number of link, J1 number of connection with a full join or lower pair like a pin and sliding join, and J2 is number of connection with half join of high pair, for example cam and gear join. This is equation applied to planar mechanism. Outside from the degree of freedom or another connecting joint, this is a coincident joint. Physically, this picture have one pin joint like this, but for kinematically you can say have 2 joint like this, because one joint connect 2 link like this. So for G1 have a 2 joint like this. For G1 we can say this is a special joint, one point joint for physically, but for kinematically have 2 joint, because one joint connect 2 link together. So for G1 we can say have number 2 of joint. Okay, this is a sample for the degree of freedom calculation you can look this picture. So first you must count the link. You can count the link. 1, 2, 3, 4, 5, 6, 7, 8. You can count this picture have 8 link. Now you can count a 41 link or a lower pair. 1, 2, 3, 4, 5, 6, 7. This is physically coincident joint have two join, but basically have one join, but for kinematically have two join. So we can count for two join for G1. So we can calculate for each join and two coincident join. So for G1 or a high pair, a lower pair join have a number of 10. How about for high pair? There is no high pair join, so J2 is 0. Now you can calculate for mobility for this equation. M equal to 3 multiply L minus 1 minus 2 J1 minus J2. So M equally 3 multiply H minus 1 minus 2 multiply 10 minus 0. So the result is 1 mobility. So we can say this mechanism have one mobility of degree of freedom. Now we can count about the second example for calculation degree of freedom. Look at the picture. This is a mechanism like this. The first calculation, you can account amount about link. First link is 1, 2, 3, 4, 5, 6. This is a have 6 link. This fixed link have a 3, but you can account for one link, because this is a fixed link for number 1. After that, you can account for lower pair join or pin join or sliding. You can account for join 1, 2, 3, 4, 5, 6, and 7. This is lower pair, 7 lower pair, and then the last you can account about high pair. You can look at high pair for this join. This is a half join, high pair, only one half pair, so J2 is 1. And then you can calculate two Hilbert equation. M equal to 3 multiply 6 minus 1, and then minus 2 multiply 7, and then minus 1. So the result for mobility is 0. This mechanism is 0 mobility, or cannot have a motion. And then the last example, this is have a special mobility. spatial mobility like this. We can account, the first account is L for link. You can account link is 4. 1, 2, 3, 4 for link. And then you can count J 1 or lower pair. The lower pair have 3 join, 1, 2, 3. And J for high pair J2 have 1 join like this. This is a high pair. And then you can account with this equation 3 m equally to 3 multiply r mean 1 minus 1 and minus 2 multiply j1 minus j2, and then you can calculate, and the result is have a 2 degree of freedom for this mechanism. This is a mechanism have a 2 degree of freedom. The first is swinging from the link, and the second is spinning from the roller. The roller degree of freedom is undesirable because the function is to prevent the cam from being one due to the friction.
Now first thing first, let us see what is a kinematic chain. Kinematic chain is a combination of assembly of joints and links. A kinematic chain is a group of links either joined together or arranged in a manner that permits them to move relative to one another. In other words, when several links are movably connected together by joints, they are said to form a kinematic chain. For example, as we can see in this figure, all the links are arranged in such a manner that permits them to move relative to one another. Next thing that we are going to discuss is how many types of kinematic chains are there. There are basically two types of kinematic chain. First is closed loop kinematic chain. If every link in a chain is connected to at least two other links, the chain form one or more closed loops. This is a closed loop chain. As we can see in the figure, all the links are connected to at least two other links. For example, link 1 is connected to link 2 and link 5. Similarly, link 2 is connected to link 1 over here and link 3. Similarly, link 3 is connected to link 2 and link 4, and link 4 is connected to link 3 and link 5. Next thing, the kinematic chain is also classified as an open loop kinematic chain. A linkage failing to meet the closed loop criteria is an open loop kinematic chain. In this case, one or more of the links is connected to only one other link. As we can see in the figure of a joint arm robot, the hand or arm of a robot, which can be considered as one link, is connected to only one other link. As we can see, the hand of this robot is only connected at this point. That is, it is only connected with one of the link. Thus, we can say that this mechanism, this joint arm robot, can be termed as a open loop kinematic chain. This is just a practical example of a open loop kinematic chain. Now, moving forward, let's discuss how we can determine whether the mechanism we have is a kinematic chain or not. Earlier, we discussed that each link forms pair with two adjacent links. Thus, if each link is assumed to form two pair with two adjacent links, then the relation between the number of pair forming a kinematic chain and the number of link may be expressed in the form of an equation L equal to 2p minus 4, where L is number of links, P is number of pairs. Since in a kinematic chain each link forms a part of two pairs, therefore there will be as many links as the number of pairs. Another relation between the number of links and the number of joints which constitutes kinematic chain is given by the expression J equals to 3 by 2L minus 2, where J is the number of joints present in the mechanism and L is the number of links that are present in our mechanism. These two equations, the equation 1 and 2, are applicable only to kinematic chains in which lower pairs are used. These equations may also be applied to kinematic chains in which higher pairs are used. In that case, each higher pair may be taken as equivalent to two lower pairs with an additional element or link. Now, let us apply the above equations to the following cases to determine whether each of them is a kinematic chain or not. These are just the two equations that we can use in order to determine whether a mechanism is a kinematic chain or not. Okay, so case 1. Consider the arrangement of three links AB, BC and CA with pin joints at A, B and C as shown in figure. In this case, there are three links, link 1, link 2 and link 3. How many pairs are there? AB and BC 1, BC and CA 2 and CA and AB 3. So there are 3 pairs and 3 links. And how many joints are there? Joint A, joint B and joint C. So there are 3 links, 3 pairs and 3 joints. Now in order to find whether this mechanism or whether this arrangement is a kinematic chain or not, we have to use these two following equations, this one and this one. So let's use it and put the values of links, pairs and joints into these two equations. First equation is L equals to 2p minus 4. Thus, if we substitute all the values in this equation, we get 3 equals to 2 times 3 minus 4, which is equals to 2. Thus we can say that the left hand side of this equation is greater than the right hand side of this equation, right? Similarly, for the second equation, if we put the values of joints and link into this equation, we get the value 3 equals to 2.5, which says that the left hand side of this equation is basically greater than the right hand side of this equation. Since the arrangement of 3 links as shown in figure does not satisfy the equation 1 and 2 and the left hand side is greater than the right hand side, therefore it is not a kinematic chain and hence no relative motion is possible. Such type of chain is called locked chain and forms a rigid frame or structure which is used in bridges and trusses. Case 2. Consider the arrangement of 4 links AB, BC, CD and DA as shown in this figure. The number of links that are present in this arrangement are 4. How many pairs are there? AB to BC 1, BC to CD 2, CD to DA 3 and DA to AB 4. So there are basically 4 pairs. And how many joints are there? A, B, C and D. Thus there are 4 joints. Okay, so now substituting all the values of this arrangement into the following two equations, L equals to 2p minus 4. When we substitute these values in this equation, we get that the left hand side of this equation is equals to the right hand side of this equation. Similarly, when we substitute the values of joint and link to the second equation, we will find that the left hand side of the second equation is also equals to the right hand side of the second equation. Since the arrangement of 4 links as shown in the figure satisfies the equation 1 and 2, therefore it is a kinematic chain of 1 degree of freedom. don't worry about the degree of freedom, we are going to discuss it in our next lecture. A little consideration will show that if a definite displacement, say theta, is given to link AD, keeping the link AB fixed, then the resulting displacement of the remaining two links BC and CD are also perfectly definite. Thus we see that in a 4-bar chain mechanism the relative motion is completely constrained, hence it may be called as a constrained kinematic chain, and it is the basis of all machines. Case 3. Consider an arrangement of 5 links as shown in this figure. Thus, how many links are there? 5. Now, how many pairs are there? AB to BC1, BC to CD2, CD to DE3, DE to EA4, and EA to AB 5. So there are basically 5 pairs. And how many joints are there? A, B, C, D, and E. So there are 5 joints. Now similarly, substituting all this value into the two given equation, which is used to determine whether this is a kinematic chain or not. When we substitute the values in the first equation, we get that the left hand side of that equation is less than the right hand side of this equation. Similarly, when we substitute the value of joints and links to the second equation, what we get? We get that the left hand side of that equation is basically less than the right hand side of that equation. Since the arrangement of 5 links as shown in this figure does not satisfy the equations, and left hand side is less than the right hand side, therefore it is not a kinematic chain. Such a type of chain is called a unconstrained chain, that is, the relative motion is not completely constrained. This type of chain is of little practical importance. Fourth and the last case that we are going to study is, consider an arrangement of 6 links as shown in figure. This chain is formed by adding 2 more links in such a way that these 2 links form a pair with the existing links as well as form themselves a pair in this case. Thus, how many links are there? 1, 2, 3, 4, 5 and 6. How many pairs are there? AE to EF1, EF to FG2, BC to CD3, CD to DA4 and DA to AE5. So how many pairs are there? 5. And how many joints are there? A, B, C, D, E and F. So there are 7 joints. Thus, when we substitute all these values of these links, pairs and joints to the given equation, what we find? We find that the left hand side of that equation is equals to the right hand side of that equation. Similarly, when we substitute the values of joint and links to the second equation, what we find? We find that the left hand side of that equation is equals to the right hand side of that equation. Which means that since the arrangement of 6 links as shown in figure satisfies the equation, that is left hand side is equals to the right hand side, therefore this arrangement can be considered as a kinematic chain. Most important thing is, a chain having more than 4 links is known as a compound kinematic chain. So this arrangement can be considered as a compound kinematic chain.
Okay, that's all our lesson today about mechanism and machine. Yeah. If you any question, don't hesitate to ask me. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.